Welcome to College Algebra. In this lecture video, we are going to continue with our chapter 4.1, discussing polynomial inequalities. I began to kind of, using certain words in my previous videos regarding to above the x-axis, below the x-axis, using the word like positive, negative, y value. So when we set y equal to 0 of a function, okay, what that means is we will actually be looking at the x-intercept, which is located on the x-axis. Okay, so when we're using inequalities for polynomial, when we set my function greater than 0 or y greater than 0, that means we'll be looking above the x-axis. All right, with the equal to and the greater than, that means we will look what's on and above the x-axis, because that's where the y values are positive as well. If it's less than, if a function is less than 0, that means the y values are negative. We will look below the x-axis. All right. If my function is less than or equal to 0, that means my y value could be negative or right on the x-axis. Then we will look on and below. All right. So there is actually two different ways we can think about the polynomial inequality. One of them is by using the graphing calculator. The other one is thinking about it on the number line. But the two together is actually still describing the same thing. So the steps on how to find polynomial inequality. The first thing is we got to find real zeros. Okay, which sometimes we call them the critical points of the polynomial. Then we can actually graph the function, or we can graph it on the number line. And once we've done that, we can begin to state the solution using the interval notation. So I'm gonna do both graphing for you, okay, to kind of help you understand what's going on. So this example says find the solution of the following polynomial inequality. So the first thing we got to do is find the real zero. So this polynomial function, okay, it's already factored for me. So if I will set each factor equal to 0, I get x equal to 0. This one with the multiplicity even, that tell me that two of my x-intercept or zeros are actually the same, which is -1. Set this one equal to 0, x equal to 7. If you think about it, x times x is x squared. This x is actually x times x, which is another x squared. That will actually give me x to the 4th power. X to the 4th power means I will have at most 4 zeros. But right now I only got 3 is because 2 of them are the same. So with the even multiplicity, my graph should turn at x equal to -1. All right. So if I will graph this function, x times x plus 1 to the 2nd power, x minus 7. Okay. X to the 4th power. So I expecting my graph, right side goes up, left side goes down. Excuse me, left side goes up, right side goes up. See how this thing go down and then it begin to come back up. All right, so if I go to my table, I will find my zeros, -1, 0, and the one located at -7. Okay, so let me take a picture of this thing. Let me just grab it for you. Oops, sorry, too loud. All right, I'm gonna give it a try. Okay. Let me make it red. Positive 7's right here. 0 right here. See how right here, when you push -1, it turns and then you curve back down that way. Curve back towards the x-axis to go to the other 0. Right there. I'm gonna put it right there. Okay, so coming from negative infinity for x, once you get to it, turn and then turn, curve back, go toward the other 0, cross it, cross at x equal to 0, and eventually gonna curve back up and cross over at 7. Okay, so express our answer as interval notation. So what's going on? This x-axis is the same thing if on the homework, if you ever see a straight line on the number line where I might say this is 0, this is -1, and 7 is way over here. You may have done something like this in high school where you have 3 critical points or 3 x-intercepts. Okay, pick a number to the left side of -1 and plug it in, see if it's greater than 0. Okay, and that will tell you, or you can see like plugging a number to the left side of -1, see if that number is positive or negative. Okay, any kind of those concept is actually the same thing as if you will look at this graph. Greater than 0 means above the x-axis. So where is this graph above the x-axis? To the left side of -1, between 0 and 1, and to the right side of x equal to 7. So when you ever need to do any indication of positive, negative, that's what that means. Positive y value means it's above the x-axis. Between 0 and 7, you see the graph is below the x-axis, that's negative value there for y. So from where to where on the x-axis, the graph is above the 0. Okay, so what x values, okay, are above, what x values in the function that will show that the y value is above the x-axis? So that will be from -infinity all the way to -1. Okay, I'm not using bracket because there's no equal to right here. Union is also -1 to 0, like a -0.5. Union, where else is above the x-axis? From 7, keep on going to infinity. Okay, and that's your answer. Alright, so first thing, identify your critical point or the x-intercept or the real zeros. Okay, then you can graph it. Alright, you can graph it. Then you can see where the graph is above the x-axis or below the x-axis. Okay, because all this is saying is the function y is greater than 0. Function y is greater than 0 is above the x-axis. So this one already factored for me again. That's awesome. So x equal to 5, x equal to -4, and +2. The multiplicity is 1, so it will cross over at these 3 x-intercept or zeros. X times x times x, okay, is going to be x to the 3rd power, so I will add most 3. And with that negative x right there, if I will go back up here, my graph should look something like this one. Okay. Alright, let's us graph it and see what's going on. Alright, my cubic function. Down, come up, curve back down, go down. So left side goes up, right side goes down. Okay, that's it going to infinity or -infinity. So even though we don't see the whole picture, but we still have an idea. Okay, we still have an idea what our picture is supposed to be. So this is -4. This got to be Oh Lord, did I mess up my sign? No. This is 2 and this is 5. Alright, looking for where the graph is above the x-axis, greater than 0. So this part and that part is from negative infinity all the way to negative 4 is above the x-axis, or where the y values are positive. Where else? So this thing I should curve down this way. Where else? This part. So that part, union from 2 to 5, because everywhere else will be below the x-axis. All right. Again, no bracket because there's no equal to on the inequality. All right. This is another x squared x to the 4th power. So if you ever do a number line thing and use a test point, pick a number to the left side, negative 4. If you try with negative 5 here, parenthesis negative 5 minus 5 times negative 5 plus 4 times 2 minus negative 5. That would be positive 70. So that's why on the number line to the left side of negative 4 is positive, because that part of the graph is above the x-axis. Okay, that's what that means, what the number line is trying to represent. All right, let's find my zeros. Set x equal to 0. All right, multiplicity is 2 right here, so it will curve at negative 1. The other x is equal to 6. So I actually, even though I only see written down 3 zeros here, technically I have 4. It's just 2 of them are the same, because the multiplicity on the negative 1 is even. All right, let me graph it. Okay, both sides will go up. There you go. So it's almost similar to the previous one. Is that the same problem? I could, yeah, almost the same thing. But this time it's looking for less than or equal to 0. Oh, where'd my picture go? Okay. Oh man, come on. Oh Lord. Jeez. It's acting up. There we go. Okay, let me get my red points here. 0, 6, and negative 1. So where are we less than or equal to 0? Okay, above it, turn, above, stays above. So after x equal to 0, it went below, and then curve back up all the way reaching x equal to 6 before it cross over, become greater than equal to 0. So that would be from 0 to 6 is below the x-axis, less than equal to 0. With the equal to, I use brackets because I suppose the loop was on the x-axis and below. Okay, that's what that means. All right, so that would conclude our lecture video 4.1. Thank you for watching.